Good evening, students. My name is Madwako Emmanuel. I will be your tutor in several mathematics topics, and today we'll be starting out with number basis. What is number basis? Number basis is a system of counting in which several units makes up a bundle. Forget about the English, we'll go into the details in mathematics. Now, there are several countings in number basis. We have from base 2 to base 10. So quickly, we'll just go back to the board and we'll be seeing what I do on the board. Alright, now this is the definition for number basis. Like I said earlier, I said we have from base 2 to base 10. Base 2, number base 2. Is called binary. We also have base 3. Sorry, always remember to write your number basis in words. Base 3. The only numbers you can see in base 3 are 0, 1, 2. The numbers you can see in base 2 is 0 and 1. Always remember, as a rule, your number base, the numbers that can appear in a number base must be 1 less than that base. If, for example, you are given base 8, the highest digit you can see in base 8 will be 7. 8 minus 1, 7. So for base 4, we'll be having 0, 1, 2, 3. Base 5 will be having 0, 1, 2, 3, 4. Number base 6 will be having 0, 1, 2, 3, 4, 5. Number base 7, 0, 1, 2, 3, 4, 5, 6. We'll be having 0, 1, 2, 3, 4, 5, 6 for base 7. Number base 8, we're having 0, 1, 2, 3, 4, 5, 6, 7. Base 9, we'll be having 0, 1, 2, 3, 4, 5, 6, 7, 8. And finally, our number base 10, which is also called denary, you'll be having 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Alright, recall that in our last lesson we looked at number bases from base 2 to base 10 and how the highest digits can be represented in each of the number base. In this lesson we shall be showing the place value of a number base. Now remember, before we go ahead, that our mathematical solvings mostly are shown in base 10. So when you see a number written out without a base written beneath it, it is assumed it is base 10. So we'll just take some examples of how number basis appears. Example 1. If I'm given 241 in base 5. Now this is a number base 241 in base 5. Remember that for number bases, the highest digit of the number base must be less than the number base itself, must be 1 less than the number base itself. So 241 base 5, it's correct because the highest number there is 4 and it is in base 5. Now, number bases are written out in powers of the base. So I'll be writing this as 2 times 5. Just follow me. This 5 will have a power, but follow me first. Now I've written out all these numbers in powers of 5, but now let's introduce the power. You start from the back. 241, now you start from the back 1. So you introduce this 5, you start from power of 0. So this one will carry power 0, this 5 will carry power 1, and then this 5 will carry power 2. That is how you number the bases. So this can be written as 2 times 5 squared is what? 25 plus 4 times 5 to the power of 1 is 5 plus 1 times 5 to the power of 0 is what? 1. Easy understood. Alright, now I want to take you a little back to your 100, tens and units, where what we did in primary school, 100, tens and unit, and then it advanced to thousands, it advanced to tens of thousands. That is called place value. Now we want to see how they actually arrived at those place values. They didn't explain that to us in primary, but you will see it here in number basis. Remember, I explained to you that when a number is written without a base, it is assumed to be base 10. For example, if I write this, if I didn't write any base under, it is assumed to be base 10. So it can either be written as 347 or I introduce 10 under. Remember that your number basis is written out in words and below the number itself. This is not to cause confusion with the number that is written. Alright, now let's expand this in number base form. To expand this in number base form and determine the place value of each of these, we are going to expand this in accordance with the number base, which is 10 here. So this is what you do. This 3, you write it this way. What do I have here? 10. Just follow me because we are going to come back and introduce the powers. 4. The number base is what? 10. What next? We have 7. The number base is what? 10. Now, to introduce the powers to this, you start from behind the numbers. We have 347, so I'm going to start from behind the number 7. Remember that your number basis, to introduce the power, you start with power 0. So this 7, we carry a power 0, 4, we carry a power 1, 3, we carry a power 2, and so on. So on this number basis that you've written here, 10, we wrote 7 as 0, so this 10 will carry the 0, this one will carry 1, and then this one will carry 2. So if we now expand it, it is 3. To determine the place value of this 3, 10 to the power of 2 is what? 10 times 10, which is 100. So this one is 300. The next one is 4. 10 to the power of 1 remains 10. So we write it as 410. And then the next one is what? 7. 10 to the power of 0 is 1. So 7 has a place value of 1. And remember that a single number is called units. The first number, units. So the place value of 3 in this example is 100. The place value of 4 is 10. The place value of 7 is units. Now we are going to do another example. We are not going to use base 10 this time. Let's use another base. I'm having 132 in base 4. Now this is another example. Example 2. We want to determine the place values of these numbers. Now remember that to expand this, you expand with the base. So I have 1 times the base 4, 3 times the base 4, 2 times the base 4. Now remember that you are introducing the powers from behind. So the 2 will take power 0, the 3 will take power 1, the 1 will take power 2. So I come back here, I introduce this 4 will carry the power 0, power 1, power 2. So once you have that, you'll be having, this will give me 1. 4 to the power of 2 is 16. So the place value of 1 is 16. 3. The 4 to the power of 1 is what? 4. And then 2. The place value 4 to the power of 0. Any number to power 0 is 1. So the place value of 2 is unit. Now check how that changes from our example 1. Now remember that in example 2 we are doing to the base of 4. In example 1 we did to the base of 10. So our place value for example 2 will be in terms of 4 and multiples of 4. That is why we have 16, which is a multiple of 4, and we have 3. The place value of 3 for this number in base 4 is 4, and the place value of 2 for this number in base 4 is what? Unit. Alright, I'll take one final example. This time I will make the numbers 4, 5, 2, 8 in base 9. Now this is the number given to us, 4528 in base 9. So we need to expand it in base 9. Remember that to expand, you multiply each of this number by the base. 4 times 9, put the brackets, 5 times 9, 2 times 9, 8 times 9. Now to introduce the powers, remember I told you that you introduce the powers from behind. So the 8 will take power what? 0. The 2 will take power what? 1. The 5 power 2 and 4 power 3. So let's introduce the powers here. The 8 has 9 to power 0, 9 power 1, power 2 and power 3. So let's expand. This will give me 4. 9 to power 3 means 9 times 9 times 9. If you are going to do that, you can punch your calculator quickly. You are going to get what? 4 is 700 and okay, are you seeing that? 700 and 9 times 9 is 81 times another 9 is what? 729. The next one is the place value of 5. The next one is the place value of 5. This is it. 5. 9 squared, that's 9 times 9 is what? 81. That's the place value of 5. The next one is the place value of 2. 9 raised to power 1. 9 raised to power 1 is what? 9. The place value of 2 is 9. And lastly, The next number there is what? 8. The place value of 8. We have 9 to power of 0. Any number to power 0 is 1. So the place value of 1 is unit. So we'll be having 8 as what? Unit. So this is the place values of the number. So we took 3 examples. This lecture will be looking at the binary system. Recall that when we're looking at the number bases, we say the binary system is a number base counting in base 2. We are looking at base 2. And remember that the only numbers you can see in base 2 is 0 and 1. An example, 101. Base 2 is a binary system. 1001 base 2 is a binary system. 11011 base 2 is a binary system. Now these are all binary systems. Recall that your binary system, you can only see 0 and 1 in binary system because it's a number base 2. So we are going to look at how to convert from base 2 to base 10. Pause it. So we are looking at converting from base 2, which is binary, to base 10.
Just start up, continue saying.
Okay, we're looking at how to convert from base 2 to base 10. Example 1. Convert 101 base 2 to base 10. Solution. Remember when we are looking at place values, we wrote out our number in base 2 and we expanded it. So if I want to expand this in base 2, I write 1 times 2 plus 0 times 2 plus 1 times 2. Then now we introduce the powers. Remember I told you, introduce your powers from the back to the front, from 0, 1, 2. So on these 2 I put 0, on these 2 I put 1, on these 2 I put 2. So this will give me 1 times 2 to the power of 2 means 2 times 2, which is 4, plus 0 times 2 to the power of 1 is 2, plus 1 times 2 to the power of 0. Any number to the power of 0 is 1. So this will give me 1 times 4 is 4, plus 0 times 2. Any number times 0 is what? 0, plus 1 times 1 is 1. So if we add all these, 4 plus 0 plus 1, we have 5. Remember that I said if you write your number without a number base, it means it is in base 10. If you write it as 5 and put 10, you are not still wrong, you are still correct. This is 10. So this is our answer for example 1. Let's take another example. example 2. I have 1101 in base 2. We want to convert it to denary, which is base 10. So all we have to do is to expand this. I'll be having 1 times 2 plus 1 times 2 plus the next number is 0, 0 times 2 plus the next number is 1, 1 times 2. And we said introduce your powers from behind. So this one will have power 0, power 1, power 2, and power 3. So this will give me 1 times 2 raised to power 3 means 2 times 2 times 2, which will give me 8, plus 1 times 2 raised to power 2 means 2 times 2, which is 4, plus 0 times 2 to the power of 1 is 2, plus 1 times 2 to power 0, any number to power 0 is 1. So this will give me 1 times 8 is 8, 1 times 4 is 4, 0 times 2 is 0, 1 times 1 is 1. So this will give me 8 plus 4 is 12, plus 0, 12, plus 1, 13. This is our answer. Close. Always remember the rule I told you. For number base x or base n, let's use base n, the numbers that can appear is from 0, 1, 2, continuously up to n minus 1. This is the basic rule for number bases, the numbers that can appear in a number base.